Going to go through the limiting reactant notes together. Go ahead and get yours out. The limiting reactant is the reactant that is used up first. When you run out of it, you stop making product. The excess reactant is the reactant you have enough of or too much of. You won't run out of it before you run out of your limiting reactant. For example, if you're making sandwiches and you have lots of meat and cheese and tomatoes and lettuce, but you only have 2 pieces of bread, the bread is your limiting reactant. The excess reactant is your meat and your cheese and your tomatoes and your lettuce. There's another example here where you're making cookies and you have 2 eggs, a cup of flour, a cup of sugar, and a bag of chocolate chips. That's how much it takes to make 12 cookies. You have 10 pounds of flour, 5 pounds of sugar, 4 eggs, and 12 bags of chocolate chips. So because you only have 4 eggs, you can only make 24 cookies. So you'll run out of eggs first. In limiting reactant problems, you'll always be doing 3 things. Your first step is to write an equation and balance it. You won't always be given one. On your quiz, you'll have to write your own equation and balance it. Then your first step is to figure out which one of the reactants is your limiting reactant. So in this problem, we've got iron reacting with oxygen, and we make iron 3 oxide. So we need to figure out, is iron the limiting reactant or is oxygen the limiting reactant? So in step number 1 here, we're going to convert to moles. We're going to convert our iron reactant to moles, and we'll convert the oxygen reactant to moles. We're starting out in grams. So with iron, we convert it to moles. Oxygen, convert it to moles. Then we're going to divide by the coefficient in the equation. So iron, there's a 4 out in front. That's our coefficient. And oxygen, there's a 3 out in front. That's our coefficient. Once you divide, the smaller one is the limiting reactant. So this one is a lower number. That means that iron is our limiting reactant. This number we found here after we divided doesn't really mean anything. We're not going to use this number in the rest of the problem. What we are going to use is the number of moles. So now, because our limiting reactant is iron, we have to start the rest of our problem with the moles of iron. It's really important that you pick the right limiting reactant. If you pick the wrong one, you're going to mess up the rest of the problem. All right, so that was step 1. We found out our limiting reactant. Step 2, we're going to figure out how many grams of the product or products we get. In this problem, we just have 1 product. So I will start this problem with the moles of my limiting reactant, which was iron. I'm going to convert just basic dimensional analysis over to grams of the product. Notice the answer is in scientific notation, has the right sig figs. There's just 1 product, so that is just that 1 step. Step 3 is to figure out how much of the excess reactant you wasted or you didn't use or you have left over. First, you need to figure out how much you used. Just like the last problem, we're going to start with the moles of our limiting reactant that we calculated. You're going to do stoichiometry over to the excess reactant. Remember, we figured out oxygen was the excess reactant back up in step 1. Oxygen was the bigger number, so it's the one we have too much of. So doing stoichiometry, I figured out that I only used 4.30 grams of oxygen. The problem told me that I started with 10 grams. You go back up here to the problem. You're starting with 10 grams of oxygen. And then I subtract. So I'm given 10 grams of oxygen, or I start with 10 grams of oxygen. I only use 4.3. So then I have 5.70 grams left over. I'm going to go ahead and walk you through the answers to the limiting reactant sheet A that you worked on yesterday. So with these problems, my step one was figuring out which reactant was the limiting reactant. So here I converted both of my reactants to moles. And then I divided by the coefficient in the equation. So the coefficient for PCl3 was 1 and H2O was 3. When I divide, this is a smaller number. So that means that PCl3 is my limiting reactant. That means I'll start the rest of the problem with this number, not, you never start with the number you get when you divide. This problem specifically said how much of the product of HCl do you get, so you only have to find that one. So I start with my moles of my limiting reactant and then do stoichiometry over to HCl. I just have 2 sig figs because in my class we look at the masses for sig figs too. So because 36 just has 2 sig figs, we have 2 sig figs in the answer. Step 3, you would need to figure out how much of the excess you have left over. I'm still starting with the same number that I started with the number 2, step 2. I convert to H2O because that was my excess reactant up here. This tells me I used 30 grams. The problem says that I started with 75 grams of water minus 30 means that I have 45 grams of H2O left, or 45 grams of water that I didn't use. Problem 2, it was the same equation. My class got a little confused on this one because they give you moles, so you don't have to do any converting. On the first step, all you have to do is divide by the coefficient, and then that tells me that water is my limiting reactant because I got 1 when I divided, which is smaller than 3. So that means that I start with 3 moles of H2O to get my product, HCl again. Again, I just used 2 sig figs because 36 has 2 sig figs. Step 3, I'm going to figure out how much of H2O I have left over. Remember, that was my excess. No, just kidding. I'm going to figure out how much of PCl3 I have left over because that's my excess. But I still start with the moles of my limiting reactant. Convert it into PCl3. So I use 136 grams of PCl3. This problem is a little bit different. I had to convert. I was given 3 moles of PCl3 in the problem, so I converted this to grams. So I started with 408 grams, and then I used 136 grams, subtracted, and I have 272 grams of PCl3 left over. The last problem, they gave you PCl3 in moles. So this one you didn't have to convert, you just divide by the coefficient 1. But they gave you 50 grams of H2O, which I converted to moles. I should have written moles, 2.78 moles divided by 3. It's a little less than the other one. So H2O is going to be my limiting reactant. PCl3 is my excess reactant. So to figure out my product, I start with the moles I calculated here, 2.78 moles of H2O. Convert it just like the rest of the problems to grams of HCl. To figure out the excess, I start with the same number, convert it to PCl3, and then I subtract. I was given 136 grams of PCl3 in the problem. I only used 126, so I get 10 grams after subtracting.